In May of 2025, the United States sent 3 letters, not to Beijing, not to a foreign government, to 3 companies, and with those 3 letters, it switched off the software that designs almost every advanced chip China makes. Not the factories, not the machines that print the circuits, the blueprints, the tools that engineers sit in front of for months to draw a chip before a single wafer is ever cut. Overnight, those tools went dark inside Huawei, inside the biggest chip labs in China, inside companies you have never heard of that build the silicon running the country. And here is the part that should stop you. China's entire semiconductor industry, the one we have spent 2 videos watching fight its way around banned machines and banned chips, had only weeks of runway left. Then, 6 weeks later, America switched it back on purpose. This is the chokehold almost nobody talks about. It is smaller than Nvidia, it is quieter than ASML, and it may be the single most powerful weapon in the entire chip war. So the question this video answers is the one that actually matters. Why would a country build a weapon this powerful, fire it once, and then put it back in the drawer? In the last 2 videos, we watched China do things it was not supposed to be able to do. It built an advanced chip without the machine it was banned from. It trained a world-class AI model without a single Nvidia chip. If you have not seen those, watch them after this one, because what I am about to show you is the layer sitting underneath both of them. Here is what nobody mentions when they hold up a finished chip. Before that chip is ever built, it has to be designed. And a modern chip cannot be designed by a human being, not by a team, not by 1,000 people with 1,000 years. We are talking about tens of billions of transistors on a piece of silicon the size of a fingernail, wired together in patterns no human mind could ever lay out by hand. So the entire industry runs on software. It is called EDA, Electronic Design Automation. It is the most important software you have never heard of. An engineer describes what the chip should do, and the software turns that description into an actual physical layout. It decides where every transistor goes. It draws the wiring. It simulates the chip running before the chip exists. It checks for errors a human would never catch. And at the end, it produces the exact file the factory uses to print the silicon. Every chip in your phone, every chip in your car, every chip in the data centers training every AI model on Earth, all of it was drawn, simulated, and verified inside EDA software before it was real. No EDA, no chip. It is that simple. To see how deep this goes, follow one chip through the software. It begins as a description, almost like code, of what the chip is supposed to do. The first tool, called synthesis, turns that description into a vast web of logic gates. The next stage, place and route, decides the physical home of every one of those billions of gates and threads, the microscopic wiring between them, solving a puzzle with more possible arrangements than there are atoms in the universe. Then verification simulates the finished design over and over, hunting for the one flaw in a billion that would turn a multi-billion-dollar chip into a useless brick. Only when the software signs off does the design go to the factory. Skip any one of those stages, and you do not have a chip. You have expensive sand, and here is the chokehold. 3 companies control it. Synopsys, Cadence, Siemens. Together they hold roughly 74% of the entire global market. 2 of those 3 are American. The third is German, but it runs on American technology and answers to American rules. And inside China, those same 3 companies control more than 70% of the market. So the next time someone tells you China is catching up in chips, remember this. The factories can be built, the machines can be reinvented, but the software that designs the chip in the first place sits in the hands of 3 Western firms. And in May of 2025, America decided to find out what would happen if it took that software away. On the 23rd of May, 2025, the United States Bureau of Industry and Security sent letters to Synopsys, to Cadence, and to Siemens. The instruction was blunt: stop selling to China. By the 29th of May, it was in force. New export controls that broadly banned the sale of EDA software and services into the country. Synopsys told its own staff inside China to stop selling, stop providing support, stop accepting new orders. The single most important tool chain in the semiconductor industry was being yanked out of the world's second largest economy. And now connect this to the last video. Remember Huawei's Ascend chip, the one that beat Nvidia by brute force and helped train a frontier AI model with no American silicon anywhere in the room? That chip, the symbol of China's independence, was designed in this exact software, made by these exact American companies. That is the uncomfortable truth sitting under the whole story. China's biggest chip victory was built on a tool it does not own and cannot replace overnight. The win was rented, and in May of 2025, the landlord asked for the keys back. So picture it from Beijing's side. The factories are still standing, the chip designs already finished are safe, but every new chip, every next-generation processor still on the drawing board, just lost the tool it was being drawn in. Engineers locked out of the software mid-project, updates frozen, support gone. This is not a ban on a product, it is a ban on the ability to invent the next product. That is a different kind of damage entirely. So America had its hand on the most powerful switch in the chip war. It pulled it. And then, on the 3rd of July, 2025, just 6 weeks later, it let go. The United States lifted the restrictions. Synopsys, Cadence, and Siemens each got word from the Commerce Department that the controls were gone. Siemens said it had restored full access and resumed selling to its Chinese customers. The blackout was over almost as fast as it began. Why? Because by July, Washington and Beijing were inching toward a trade truce, and the EDA ban quietly became a bargaining chip. China gave ground somewhere else, and the software came back on. And that is the real lesson of this entire episode. America did not keep the weapon aimed at China, it showed China the weapon, proved it worked, and then holstered it. Think carefully about what that tells you. You do not put a weapon away because it is weak. You put it away because it is so decisive that firing it for good would cost you your leverage. A ban you never lift is just a fact of life. People route around facts. But a ban you can switch on and off whenever you like, that is not a fact. That is a leash. And EDA is the leash America keeps around the neck of China's chip industry. But China saw the leash, and it is now spending enormous energy trying to cut it. The two names to know are Empyrean, also called Huawei, and Primarius. These are China's homegrown EDA champions, and they are growing fast. In 2025, Empyrean pulled in over 1.33 billion yuan in revenue. Its full process tools have reached roughly 35% penetration among Chinese fabless chip designers, the companies that design chips without owning a factory. And its biggest customers are not small names. They include HiSilicon, the chip arm of Huawei itself, and ZTE. That is real progress, genuinely. But here is where you have to be honest about the size of the gap, because the headline and the reality are two different things. There are two broad halves to chip design, analog and digital. On the analog side, and at the older mature manufacturing nodes, 28 nanometers and above, China's own tools are genuinely usable today. That part is close to solved. If that were the whole game, China would already be free. But it is not the whole game. The digital side is where the wall stands. The hardest and most valuable steps in the entire flow, logic synthesis and physical implementation, the steps that take billions of transistors and pack them into the most advanced chips on Earth, those remain the deepest bottleneck. That is the exact part China still cannot do at the leading edge with its own software. And the leading edge is where the most powerful AI chips are born. And the numbers do not lie. As recently as 2024, China's self-sufficiency in EDA had only just crossed 10%. 10%. After years of investment, after a national obsession with chip independence, more than 9 out of every $10 of design software still came from outside the country. So why is this the hardest layer of all to copy? Why can China build chip factories and reverse engineer banned machines faster than it can write design software? Because EDA is not just code, it is 40 years of accumulated knowledge frozen into a tool. These programs have been refined for 4 decades, tested against millions of real chip designs, and tuned hand in hand with the very factories that print the silicon. The software and the foundry grow up together, each one shaped by the other. You cannot simply hire brilliant engineers and leapfrog that in a single year. You either have to live through 40 years of mistakes or find a way to skip them. Think of it this way. Imagine being told to rebuild the most complex software on Earth from scratch, 40 years of it, with almost no one who has ever written it willing to help you, while the only people who truly understand how it works sit on the other side of a wall. And imagine that even if you somehow matched what exists today, the target keeps moving, because the companies you are chasing ship a better version every single year. That is the race China's EDA engineers wake up to every morning, and China is trying very hard to skip them. In March of 2025, Empyrean announced it was extending its digital design platform to support advanced nodes below 7 nanometers, exactly the territory that matters most. By August, it had unveiled the country's first full-process EDA platform for memory chip production. The progress is real, and it is speeding up, but the leading edge, the place where the most advanced processors are designed, is still a chase, not yet a victory. So step back and look at the whole board. 3 videos, 3 layers, the machine that prints the chip itself, and now the software that designs it. At every single layer, China has proven it can survive a ban. And at every single layer, it is still one move behind on the thing that matters most. The chip war was never really about chips. It is about the tools that make the chips and the tools that make those tools. EDA is the quietest weapon of them all, and quite possibly the most decisive. America understands that completely. That is exactly why it keeps that switch within arm's reach instead of throwing it away. But there is one layer even further up the stack. Above the software that designs the chip, there is the blueprint the chip is built on in the first place, the fundamental architecture, the instruction set, the invisible rulebook that every single processor on Earth has to obey, and the small handful of companies that own it.